Okay, hey ladies and gentlemen. Okay, so the question that we're doing is taking a look at momentum in 2D, where we have a glancing blow. We don't have a direct blow, but we have a glancing blow. This is what we're taking a look at. Sorry, technical problems. Okay. Technical problems still. Goodness gracious. Okay. So this is momentum collisions in 2D. Okay. Also known as a glancing blow. Glancing blow. Okay. So the question is, how do we know that my momentum is conserved in 2 dimensions? And we're doing this question. This is from the old textbook, old Nelson Physics textbook, sample problem number 2, page 256. And the question is as follows. So it says, in a game of marbles, a collision occurs between 2 marbles of equal masses. So we're starting out with something straightforward. Mass 1 equals to mass 2. So my marbles have exactly the same mass. One marble is initially at rest, even better. So let's say V2 equals to 0. Okay. After the collision, the marble acquires a velocity of 1.1 meters per second at an angle of 40 degrees from the original direction of motion of the other marble. So I want you to think about it. So you had 2 marbles. There was marble 1. This is marble 2. This is marble 1. This is moving. This is stationary. So V2 equals to 0. This marble comes and hits it and causes my 2 marbles to go off at an angle like so. Okay. Now this is V2 prime and this is V1 prime. Okay. And V2 prime they said was, this is 100 or 1.10 meters per second. And this right here is 40 degrees from the horizon. 40 degrees from the horizon. And the other marble, the V1 prime, has a velocity of 1.36 meters per second. And we do not know what this theta is. We don't know what this angle is. So the question is, what is V1? With what velocity did my original marble travel at before it hit the stationary marble? Okay, this is what we're looking at. Okay, all right, so what we're going to do is we're going to say, of course, that momentum before equals to momentum after. And we're starting with m1 v1 plus m2 v2, which equals to m1 v1 prime plus m2 v2 prime. And of course, my object here was at 0. Okay, and we said all the masses are equal. So we end up with the following. We end up with v1, which equals to v1 prime plus v2 prime. Are we okay? So far so good? Yeah, all the masses cancel out because they're all the same. All the masses cancel out because they are all the same. So now what we need to do is as follows. Now this right here is the velocity in the x direction, correct? You're like, oh my god, I thought I left vectors in chapter 2. No, you didn't. Back with a vengeance. Okay? So this was the velocity in the x direction. This is your velocity now. Of course, it's made up of an x and y. Does that make sense? So this is your v2 prime y, and this is your v2 prime x. So far, so good? And this right here is your v1 prime y, and this is your v1 prime x. We okay so far? Okay. So what we're going to do is we're going to take a look at the following. We're saying that before my collision, did I have a y component of my velocity? And the answer is No, there is no y component of velocity. So if I break this down, I get v1y, which equals to v1 prime y plus v2 prime y. So far so good? Okay. All right. Now you can exactly see where this is going. Some of you can actually figure out, okay, I know what exactly is happening. So what we're going to do is we're going to plug our 0 in. Before my collision, I have no y component of velocity. So 0, which equals to, now v1y is going to be the sine of theta. I don't know what theta is, times v1 prime, which is 1.36. Okay, so let me not even put that in. Let's just put variables first. So this is going to be v1 prime. And this is going south plus my v2 prime, and that is going to be, again, sine of 40 times v2 prime, and that is going north. Okay, plug our numbers in. So you get sine theta times 1.36 going south plus sine of 40 times 1.10, and that is going north. Capiche? All right, can you give me the values of these, please? What is sine of 40 times 110? 0.70. So of course, because this is north and this is south, we're subtracting the two. So I'm going to subtract it right here. This becomes 0.707. Okay. And this right here is just going to be sine theta times 1.36. Okay, minus 0.707. Okay. And of course, this is also going south now. And this is going south because I subtracted it. Okay. We're going to go back to before, erase some of these. Okay, and we end up with the following. So we bring it over to the other side, so it becomes 0.707, which equals to sine theta times 1.36. Okay, 0.707 divided by 1.36, which equals to sine theta. Do inverse, sine inverse, 0.707 divided by 1.36. And what is your theta? How much? 31 degrees. So it says 31 degrees from the horizon. So this is step one, figuring out my angle. So far so good? Okay. Now we are going to take a look at the x direction. Okay. And in the x direction, can I erase this bottom part right here? So in the x direction, we have again v1x, which equals to v1 prime x plus v2 prime x. Now we don't know what v1x is. We're looking for that. So v1x equals to v1 prime x, which is going to be the cos of 31 times 1.36, and that is going east, plus, again, cos of 40 times 1.10, and that is also going east. Please calculate those values. What do you get? What is your v1x? What is this first? What is cos of 31 times 1.36? 1.16. 1.165 meters per second going east, plus, what is this one right here? Cos of 40 times 1.10. 0.84 meters per second also going east. Add the two together and you get a v1x, which is exactly 2.0 meters per second. So the ball was traveling at 2.0 meters per second before the collision. And this is it. Okay? Easier than perfectly elastic collisions. Okay? Now you know when I give you the test, I mean, they shouldn't take you that long except for that one question. Okay? All right, so this is an example where My masses are exactly the same. What if they're different? What if they are different? Of course. We can't just erase stuff then. Okay. Okay. Okay, so the question is old textbook again, sample problem number 1, page 254. And the question says a 38 kilogram child is standing on a 43 kilogram raft. So you've got a raft and you've got a child standing on it. There's my art. Okay. So mass of child is 38 kg and mass of raft is 43 kg. Okay. That is drifting with a velocity of 1.1 meters per second. So I've got a velocity going up. So velocity prime, or I should say velocity, is 1.10 meters per second going north. Okay. All right. The child then walks on the raft with a net velocity. So the velocity of the child is 0.71 meters per second going east. Okay. Relative to the water, fluid friction between the raft and the water is negligible. Determine the resultant velocity of the raft relative to the water. So what happens? I was going north before. Now the child walks east. So what happens to the raft as the child walks east? What's that resultant velocity? So we're looking for the velocity of the raft. This is prime. This is prime. What is that prime? Okay. So what we're going to do is first we're going to figure out my momentum of my system, which is going to be m times v of the system meaning both the child and the raft put together. Okay. And this is going to be 43 plus 38 times 1.10. And again, you get momentum of the system, which is 89 kilogram meters per second north. So this is my original momentum of the system. And now we're going to say, of course, that the child causes, so P of the system, okay, after, is made up of the child's after plus the raft after. Child after and the raft after. This is the momentum of the system before. Now I know that the final momentum of the system should not change, is conserved. That's what we're saying. So we're going to figure out, we have this because we're given 0.71 times the mass of the child, and we're trying to figure out what is the mass of the raft. Okay, so we're going to do PR prime, which equals to PS prime minus PC prime. Okay, now remember this was vectors, so you remember vectors and what happens when we subtract vectors. Yes, I know, we don't like that stuff. So we're going to do, this is PS prime plus negative PC prime. Okay. Okay, and the next thing that we're going to do is now we're going to take a look at the raft's thing. So PR prime squared, which equals to PS prime squared plus PC prime squared. Okay, and this was given to me already, so this was 89 squared. Okay, and this right here of the child is, we already know that it is 38 times 0.71, and you get PC prime, which is 27 kilogram meters per second. Okay, so this is plus 27 kilogram meters per second squared. Okay, and you end up with PR, which equals to 93 kilogram meters per second. Okay, this video is going to end, but you get the picture. Find out the theta of it, and the theta is going to come out to 17 degrees.